Myself, Benilda, Assistant Professor in the Department of Artificial Intelligence and Data Science at Sri Muthukumaran Institute of Technology. Today we are going to see the subject 3D printing and design. The subject code is CCS 331 Regulation 2021. In previous part 1 video we have seen the unit 1 introduction of 3D printing. In this video we are going to see the next topic, design consideration. So design consideration refers to the essential factors, principles and constraints that must be taken into account during the design process of a product. These considerations ensure functionality, safety, aesthetics, efficiency, cost effectiveness and usability. So today we are going to see about the material selection, size consideration and resolution in 3D printing. So first of all, material selection. So the choice of a material affects the strength, flexibility, durability and aesthetic properties of the printed object. The most common materials used in 3D printing include polylactic acid, acrylonitrile butadiene citrine, polyethylene terephthalate glycol, nylon, resin and metal powders. So polylactic acid is a biodegradable. It is easy to print and suitable for the prototypes. Next, acrylonitrile butadiene citrine is strong, impact resistant and heat resistant. Then this polyethylene terephthalate glycol, a balance between a PLA and a ABS resistant to moisture. The nylon gives high durability, flexibility and resistance. Resin is used for high detail prints, available in standard, tough, flexible and castable variants. Finally, the metal powders used in industrial applications for strong functional parts. So now we can see these materials one by one. First of all, polylactic acid. So polylactic acid, commonly known as PLA. It is the one of the most popular material used in 3D printing. It is one of a highly efficient biodegradable plastic. It is a thermoplastic. It is the same plastic that is used in the biodegradable plastic cup with the green band around it that you get at the restaurant, or a plastic container of strawberries you pick up at the grocery store. This is the default filament in extrusion based 3D printers because it do not need heated bed and can be printed at a low temperature. Next one is ABS, that is acrylonitrile butadiene citrine. It is a popular thermoplastic polymer. It has been extensively used in manufacturing automotive parts. This ABS provides good all-round performance for electrical enclosures, computer keyboards, etc. It is used in 3D printing due to its strength, durability and heat resistance, making it suitable for functional prototypes and end-use parts. Next one is polyethylene terephthalate glycol. It is also called as PETG. It is also a thermoplastic polyester. This is used in a variety of consumer and commercial applications. It's known for its durability, chemical resistance and ability to withstand high temperature. Besides PETG, actually it is impact resistant and naturally colorless with high transparency. Some of the applications of this PETG are signboard, IC tube, toothbrush handle, medical sterile packaging, cosmetic packaging, vacuum cleaner parts, washing machine cover, refrigerator boxes, and etc. Next one is nylon. This nylon is also one of the most popular 3D printing materials for producing strong functional parts using functional prototypes and end-use parts for electronics, automotive, aerospace, medical devices, consumer goods and more. This nylon has used in 3D printing for over 2 decades. In filament form, it is used with fused deposition modeling printers. In a powder form, it is suitable for selective laser sintering and multi-jet fusion processes. Next one is resin. It is a form of 3D printing technology used for creating models, prototypes, patterns using photochemical processes by which light causes chemical monomers and oligomers to cross-link together to form polymers. It uses a photosensitive resin that is solidified by a laser beam, creating objects laser by layer fashion. It is known for its high resolution and smooth surface finish. Next one is metal powder. This is a metal additive manufacturing process where a laser selectively melts and fuses metal powder layers to create 3D parts. It is used to build objects out of almost any metal alloy. During this process, a laser is slowly and steadily moved across the surface to sinter a very thin layer of spreading metal powders, which mean that the particles inside the metal are fused together even though the metal is not heated enough to allow it to melt completely. In this way, DMLS gradually builds up a 3D object through a series of very thin layers, even porous metal components. So this is about material selection. So some of the consideration when selecting a material. So consideration must be made to minimize required support material, ensure a reliable print with the best surface quality and maximize strength. So mechanical properties like strength, flexibility, heat resistance should be taken into consideration when selecting a material. Next, printability and ease of use. So how easily the material can be printed without errors or special settings. Next one is post-processing requirements. It is extra work needed after printing like cleaning, curing and polishing. Finally, environmental impact and cost. How eco-friendly the material is and how much it costs. So this is about the material selection. Next we can go to the size consideration. So the size of 3D printed object is constrained by build volume, shrinkage and warping, segmenting large print orientation. So build volume means the maximum dimensions a printer can print in X, Y and Z axis. Then shrinkage and warping. Some materials contract after cooling, affecting the final dimensions. Next, segmenting large prints. Large models may need to be split into multiple parts and assembled parts later. Next, print orientation. Orientation can impact strength, aesthetics and required support structures. So this is also important in 3D printing. Finally, the resolution in 3D printing. 3D printer resolution refers to the level of detail and accuracy that a 3D printer can achieve when creating an object. It is usually measured in microns or millimeters, where a smaller number of indicates a high resolution, thus providing a more detailed and precise final product. The resolution of a 3D printer can depend on various factors including the printing technology used as well as the quality and capabilities of the printer itself. So first of all, layer height, that is vertical resolution. So this refers to the thickness of each layer deposited by the printer, with the thinner layers generally leading to smoother surfaces and higher resolution. Next one is horizontal resolution. This refers to the smallest movement the printer's head can make in the x-axis and y-axis. and is often linked to the nozzle size or laser diameter in different printing technologies. Then fused deposition modeling. The nozzle size and the smallest possible movement a printer can make side to side are major factors in determining the resolution. Next, the factors that affect the 3D printing resolution. So some of the primary factors are there that impact the resolution of 3D printer. So layer height is one of the most significant factor affecting resolution, especially in vertical terms, that is z-axis in layer height. It is the thickness of each layer of material substance that is deposited during the printing process. A smaller height results in a finer detail and a smoother surface finish, as it reduces the visible layer lines and allows for better reproduction of intricate details. Next one is nozzle size. The size of the nozzle on the 3D printer directly impacts the resolution of the printed object. A smaller nozzle diameter can deposit material more precisely, allowing for finer details and sharper edges in the finished product. Finally, print material. Different material have different properties such as viscosity, melting point, tensils, strength that can affect how accurately the printer can deposit the material and maintain the desired level of detail. So some of the typical resolutions: lower means 300 to 400 micrometer. It fast prints and rough surface. Then medium 100 to 200 micrometer. This balanced between speed and quality. Then high means 50 micrometer or lower. It will give a very fine details and it is a slower printing speed. So this is about design consideration. In the next video we can see about printing processes. Thank you.